Hey guys, this is Mr. Piercy, and what I'm going to be doing today is demonstrating the properties of the angles of a quadrilateral that is inscribed inside of a circle. For the demonstration, I'm going to use a compass, a protractor, and a pencil, and we're going to begin by starting off with a circle that is big enough for us to add some things to it and measure some angles. So here I have a circle that I will call circle M, just to give it something. And what we're going to do now is I'm going to pick kind of four randomish points on my circle, and we're going to construct a quadrilateral inside of the circle. Now, if you're trying to recreate this on your own, there is absolutely no need for you to try and mimic the points. You don't need to copy and try and put your points to match where mine are. Ideally, the point of doing these demonstrations is that everybody should get the same results, regardless of necessarily the type of quadrilateral that they're creating. So we're going to say A, we're going to label these points B, C, and D. So I want to measure what are the measurements of these angles. So we need to know the measurement of angle A, angle B, angle C, and angle D. So we're going to use our protractor to measure what these angles happen to be, and I'm going to have to turn my paper here so I can get a good angle here. And this one on mine looks to be right about at 105 degrees. Let me move it here so we can kind of see. We'll zoom in a little bit. So that's right about at 105 degrees. So 105. Moving on to angle B. Let me just turn my paper around so it's easy for me to measure it. And this one here, there we go, get it on there. That one there looks right about 81 degrees on my protractor. So angle B, 81 degrees. Angle C, you can kind of keep it here so you can see it. Here, that one looks on mine to be right at about 75 degrees. So I have 75 degrees here. And finally, angle D, when I measure this angle, if I could get it on there fine, when I measure this angle here, I'm getting it right at 99 degrees. So 99 degrees. Now the interesting thing about here is if you look at the consecutive angles, angle A to angle B, if we looked at those, certainly they're not congruent. 81 is not half of 105, so there's no relationship of them where one is twice as much as the other one. And if I look again at consecutive angles, if I look at here, angle B and angle C, same thing. They're very close in measurement to each other. There's only 6 degrees difference, but so the consecutive angles inside of the quadrilateral don't have any particular relationship. But what we're really looking at are the angles on opposite sides of the figure. If I look at these two, clearly 105 is not double 75, or 75 is not half of 105. But what we do know is if I take the sum of those two angles, I'm going to get 180 degrees. And if I look at the other two angles that are across from each other, angle B and D, 81 and 99 are also supplementary to each other. So that's also 180 degrees. Now ideally you should be seeing something like that on your construction if you're working this here, but the conclusion that we're going to be able to draw is that the opposite angles of an inscribed quadrilateral are supplementary to each other. This is also last little kind of vocabulary tidbit. ABCD this has a particular name. A quadrilateral that's inscribed inside of a circle is called a cyclic, or some people would pronounce it a cyclic quadrilateral. So that's it for this demonstration. Again, just to recap, a cyclic quadrilateral, or a quadrilateral that is inscribed inside of a circle, the angles on opposite sides of the figure will be supplementary to each other. That's it for this demonstration.